Example, let G is equal to 1a square a cube be a group, and H is equal to 1 comma a square is a subgroup of G under multiplication. Find all the cosets of H. So here G is a group, H is a subgroup. We have to find all the cosets of H. So here why it is given a raised to 4 is equal to 1. That means a raised to 1 is a raised to 2 is a square, a raised to 3 is a cube, a raised to 4 is 1. Okay, so G is set of all elements including the identity, because in a group always you have the identity element. This subgroup 1 comma a square. Okay, now find all the cosets. Let us find the right coset. Right coset means you have to take the elements of G to the right side. H into, what are the elements of A? Elements of G, 1, a square, a cube. So H into 1, H into H into a square, H into a cube. So these are the what is that? Right cosets of H, right? Right coset of H. H into 1, right coset of H into a, right coset, H into a square, H into a cube. So now what is H into 1? We can, okay, so let me take this. G is 1a square, a cube. So left, these are right coset, right? Right cosets. Right cosets implies H1 is, you see we have, these are elements from G, okay? These are elements from G. We have to take for all A in G. For every A in G, we are defining HA, okay? HA, this is HA. A is 1, a square, a cube. Now what is H into 1? So 1 into 1, we get 1. 1 into a square, it is a square. Now second, H into A. So or A into H. We take H here, H is 1. 1 into A. What about H value? H is a square. A square into a cube. Okay. Now H into a square. H is 1. 1 into a square. A square. A square into a square. H is a square, right? A square into a square, a raised to 4. Now again, a cube is here. 1 into a cube. A square into a cube, a raised to 6. Okay, this is a cube into a square, right? 3 plus 2, 5. A raised to 5. So in the, you see you have only up to a cube, right? In G you have up to only a cube. Also we have a raised to 4 is 1. A raised to 4 is 1. So we can rewrite it as 1 comma a square, because a power 4 is 1 and a square. What is 1 comma a square? 1 comma a square is H into 1. Okay, this is equal to H into 1. So they are identical coset. Okay, H a square and they are identical coset. H, this one, H1 and H a square are same. They are identical. Now when you come to the next case, a cube, a power 5 can be written as a power 4 into a, which is equal to a raised to 4 is 1. So we write a cube comma a power 4 is 1. 1 into a. So a cube. You see a cube is here. A cube is HA. This is equal to HA. So HA and H cube A cube, A cube. They are identical. Okay. So H1 is equal to HA square. HA is equal to HA cube. So they are equal. So how many right coset are here? We have only 2 right coset, 2 different right coset means we have only 2 distinct right coset. Okay, there are only 2 distinct right coset. Similarly, you can find the left coset also. So this is how we find the cosets. Next example, find the left coset of 0, 2 in the group Z4, comma plus 4. Let Z4 is equal to set of integers that start with 0. Okay, we take the first 4 elements. 0, 1, 2, 3. Okay, 4 elements we can take, and it is defined with addition modulo plus 4. And Z4 is a group and H is equal to 0, 2. This is the given find the left coset of 0, 2, set 0. This is taken as H. Now we will find the left coset, that is for all the elements of Z4. Therefore 0, H, here it is defined with respect to plus. So 0 plus H, 1 plus H, 2 plus H, 3 plus H. So what is 0 plus H? 0 plus, if you add 0, you get the same H itself, right? So 0 to itself, H itself. When you take 1, 1 plus H, you increase by 1. 0 plus 1, 1, 2 plus 1, 3. So 1, 3. So you get 1, 3 here. Okay, now next term. 2H, increase, you can increase 2 here. If you increase 2, 2 plus 0, 2, 2 plus 2, 4. So you get 2, 4. So 2, 4, whenever you take 4, it is addition modulo 4, right? 4 should be considered as 0. 4 should be considered as 0. Since Z4 has only 0, 1, 2, 3, and with respect to addition, 0 is the identity element here, okay? 0 is the identity. So if you take 4, that will be equal to 0. So here 4 means 4 plus 0, you can get to 0, 5 means 4 plus 1, that is 1, 6 means 4 plus 2, that is 2. So these elements, so we should find such that they belong to this set Z4, okay? So this 5, 6 is not an element, 4, 5, 6 are not here. So we can rewrite it like this, 0, 1, 2, etc. So now, when you come to this, 1 plus H is 1, 3, 2 plus H is 2, 4, 4 can be replaced by 0, 3 plus H, what is H? 0, right? So increase 3, you can increase 3, 3 plus 3 comma 5, but what is 5? 5 can be taken as 1, because addition modulo 4, right? We write addition mod 4 means we have to take that extra positive integer here. So that positive integer is 1 here. So this is 0, 2, this is 1, 3. So 0, 2 means already we have 0, 2, that is H. 1, 3 means already 1, 3 is 1 plus H, right? 1 plus H. So these are repetition, right? These are repetition. So only 2 distinct left coset are there, okay? Only 2 distinct left coset are there. Now we will go to the next definition, normal subgroup. A subgroup H star of G star is called a normal subgroup if for A in G, AH is equal to HA. A subgroup H star of G comma star is called a normal subgroup